Alright guys, so I had a comment come in. Says great puzzle tutorial, really well paced, informative, and easy to follow along. Is talking about my symbol puzzle that had like the rotating tables and pillars and whatnot. So would love to see a future puzzle video very similar to this one, but instead of pillars and symbols, you have point lights that you have to change to the correct color for a door to open. Looking forward to future tutorials. First of all, thank you very much for posting that. Yeah, I'm always looking for more puzzle ideas. If you guys want to see any puzzle ideas being created, please send them in to me and I'll see what I can do. But the biggest thing that I would suggest for you guys is try to simplify it as much as you can, as far as go ahead and try to create it yourself. A lot of the information you guys are going to find from these videos is I'm just simplifying it all the way down to the point where I'm just basically passing numbers back and forth between different objects and it checks those numbers. So without further ado, let's just dive right into it. I am going to be making this one completely on the fly, so hopefully I don't screw it up, but yeah, let's get into it. All right, now that we are loaded in, actually I want to have my stream up on the other side, or my recording up on the other side so I can see stuff. I'll get rid of this gun because we don't need it. All right. First thing I want to do is I want to go ahead and create a new folder in here, call it the light puzzle. Open it up, and inside of it we're going to make a blueprint interface, and this will be our use underscore, I can type, interface. And inside of here, really all we need for this is just a very generic interface I make every single time. We just need to call this something like on use, something descriptive, and I just need to pass through actor object reference. So grab our actor object reference, and I'm going to name this input actor. So basically, every time that use gets called, we're going to pass through what actor is trying to use something, and then we'll do whatever the logic is that the specific thing that's trying to be used is supposed to do. So if it's a door, then open the door. Okay, so then we want to make our puzzle pieces. So I'm going to do a new blueprint class, actor, and this will be BP underscore light underscore, I was about to say PP, but that would just come off as hilarious. So we'll go with light puzzle piece. And we will first make let's just do a static mesh. And then we can set this to like a cube. We're going to use a lot of cubes today, I feel like. Do shape cube because it sits around the X there, and I think I'm just going to squish it on the X like 0.25, or let's go 0.02, 0.05. Yeah, there we go. And then we're going to grab a point light, put it on here. Let me see if that's on the correct side. So I'm going to put this here. No, it looks like it's on the inside. Both of them are. So I'm going to grab the point light and I'm going to flip it here. And I'm going to take the static mesh and go forward 1. So to actually negative 10. And that's going to pop us out a little bit. Put this grid here off and maybe bring it back slightly to like 0.5 or something ish. There we go. That should sit really nicely on there. First thing I want to do with that point light, I'm going to take down the intensity, so 2000, and make it where it doesn't cast shadows because we really don't need it, and that's going to be a little bit of a performance hit. Not really performance hit, but it could interfere with other lighting that you'd want to have in the level. Okay, so first thing we want to do is go to our class settings, and we want to add that use interface by coming down here to implement interfaces, hitting add and searching for our use interface. That'll give us this nice function here. We can double click on it and that'll implement it for us. Whenever this light receives that use interface, then we want to update the color somehow. So I'm thinking maybe track it by an index. So we can call this the color index. And we can set this to an integer. And so every time use is hit, we can just increment that index by, if you want this, just type in either increment or plus, either way. And if it is equal or actually every time that this gets incremented, we want to, let's try a new function. We want to update the light color, right? We can take our point light and put this to the side here for a second. Actually, we want to grab our color index. We can do a switch on int. And what this does is it takes in an integer, so 0, 1, 2, 3, 4, 5, whatever. Takes that and say 0, 1, 2, 3. We have 4 of them. And we can say if it's 0, then do this. If it's 1, do this. If it's 2, so on and so forth, right? And if it's something that's not in that list above, do the default. So we can take our point light and we can say set color. If it's 0, I'm going to go ahead and set it to be white. The reason for that is because it's going to start off as white, and whenever we hit that plus plus, it's automatically going to switch to 1. So this, the very first time it runs, is going to go through 1 and not 0. So whatever we want our first color to be will go through 1. Okay, and then we can just set that to like a greenish, the blue, there we go, green, let's do red, so a nice opposing color here, and then a blue, just for simplicity. Okay, so every time this comes through, we'll pick its color. Then we can actually, we want to make sure this is one of the things that this is going to do. So every time it comes in, it's going to go 0, then it's going to go 1, 2, 3, 4, 5, 6, right? We need to put a cap on it somehow. So we could check if this number is still less than or equal to the max integer, which if we go back into our update light here, the max index that we had is 3. So we set it to our max index. And if it is correct, if it's still underneath that, then we can just update our light color. If it's not, then what we want to do is go ahead and set. So if you hold Alt and drag color index back out, we can just set it back to 0. So holding Alt and dragging it out gives you a set. Holding Control and dragging it out gives you a get. Okay, and then we can say set it back to 0, and then copy. Actually, we don't have to copy paste. We can just drag like that, and there we go. We can then update the light color right after we set it back to 0. So that, if we put one of these in the world, which I already have one. Oh, we don't have a way of interacting with it. So let's go ahead and write that. I just thought about that. So in order to interact with it, we need a couple of things. So we'll go first person blueprint. We're gonna go to input, into actions. We're gonna right click, go to input, input action. It's a lot. And we're gonna name this IA_use. We're gonna open that up. I'm gonna go on to triggers, and under trigger, I'm going to add a new pressed. Save. And then we're going to go down to our input again. Go to not action, sorry. Go to the IMC default, open that up. We got mappings here, so we have this plus next to it, add a new mapping, find our use, and then we're gonna set our key. So just click on the keyboard, it turns yellow, click the key that you want on your keyboard, and there you go. Nice and easy. Now we can come back to our blueprints folder for our first person character, open the first person character, right click, and we can say IA_use. There it is, this top one. Pull off of here. Now we can do a line trace. So we can pull off and say line trace by channel. If you wanted to, you could use an overlap event, however you want to do it, but in our case, just do a line trace, nice and simple. So we're gonna grab our first person character. We're gonna get its world location. Pull this back a little bit. And then we're also gonna get its forward vector. So basically, where is it and where is it looking is what we're looking at here. Now this forward vector is kind of an offset. So what we want to do is we want to take that offset and say for it to go forward, since we're using the forward vector, if you're using the right vector or whatever, you could say go to the right so far, or you could multiply it by a negative number and go to the left so far, or same thing with forward, you could multiply it by a negative and have it go back so far. So in this case, we're going to multiply it by a float, and I think I usually go with like 350. Works pretty well for short range use. Maybe you might even want to go a little bit shorter than that. However you want to do it, it's up to you guys. But basically this 350 is your use range. How far away can you be from something when you hit E? Will it interact with it? So that's the number you guys want to change if you feel like it's too far. We're going to take our world location and we're going to plug that straight in the start. And then we're going to take it and add it to this offset that we created. And that'll be our end. Okay. And then I'm going to do a draw debug and we're going to do for duration. If you want to change how long the duration is, which I'm going to do mine for like 1 second. Switch our draw time. Now I'm going to hold B, left click at a branch, plug that into our return value here, basically saying, did we hit something, right? And if we did, then we want to break this hit result and find out what exactly was it that we hit and does it meet the conditions that we wanted to. So I'm going to pull off the hit actor and say, does this guy implement an interface? If it does, is that interface the use interface? So that is what I called it, right? Or do we ever make the user interface? Sorry. Am I jumping way ahead here? Yeah, we did. Use interface. Oh, use underscore. There it is. I just didn't see it a second ago, I guess. And if it does implement that user interface, then I'm going to hold B, left click, open this guy up, and check. If it does, then we want to do something. And basically in this case, the something that we want to do is the on use event that we created in there. Make sure you get the message one. It'll have a little envelope. And then we also want to pass through who is trying to use it. In this case, it is ourself. Actually, in most cases it'll be self, but in this case, the self is the first person character. And that should be all we need to do in here. This is a nice little easy way of making a use event. I know it looks like a lot of code, but it's really not. It's just really big nodes. So now we should be able to run up and press E on this guy and its light changes. And you see that little red marker? That's where this is hitting, as you can see. So you can see the light change. So now we need something that can detect if that light has changed. And we probably want more than just one of these. So I'm going to take this, I'm going to hold Alt and drag it out and drag it out. We'll do 3. Okay. So now we want something that can check all 3 of these and make sure that they are the correct color for our door to open. So I'm going to make a new actor and call this BP underscore puzzle checker button. And we're just, it's just not a plane. Sorry, let's just do a cube. And let's do like 0.3, 0.3, 0.3. And go to event graph, class settings, and get our use interface. Open it up. And so whenever this thing is used, we want to find out first of all, what puzzle pieces are we using? So we can just call this puzzle pieces, make a new variable, sorry. And this will be our light puzzle piece. Object reference. I'm going to right click on this to make it an array and click the add all to make it instance editable. So we want to get all of these puzzle pieces and say for each loop with a break. Hopefully I'm right about this. It's going to be a really long video if I'm not. But so we get a for each loop with a break, and we can get that color index that we made and find out if it matches up with our code. So what we can do is make a color code variable, and this will just be an index. Still keep it as an array, but also make it instance editable. You can pull this out and say get your copy really quick. And then we can plug in the index from our loop here to check the code. That's why it's going to matter a lot when we set up the checker here, which actually I'm going to go ahead and do that since we're already talking about it. Put this button here, and we'll have a door here to the right. Whenever this is pressed, it needs to be able to check from left to right or whatever order you want to put them in, but you need to remember that order. So easiest way to do it is we can hit the plus on here, and here's our puzzle pieces. So we can say that's the first one, that's the second one, that's the third one, and that needs to directly match our code here. So let's say we have 3 digits to our code. The first index of this code is referencing this guy. Is this one 0? Is its current color index set to 0? Or, you know, we could do 3, 1, 2. So is this one 3? Is this one 1? Is this one 2? And if all 3 of those are correct, then we want to open that door. That's the basic concept of this whole thing so far. So, and actually, speaking of which, if they're correct, we need to make a new variable called is correct with a question mark so we know it's a Boolean. And I'm gonna make that single, right? I'm gonna hold S or Alt and bring it out so that we get a set. And then we're gonna, each time that use is called, we're gonna set this to correct. And then we're gonna check, is it actually correct? Say, so if this color is actually not equal, so if you do an exclamation point, they're not equal to this one, then we want to stop all this and say, hey, wait, hold on, this isn't correct. So we can set this to is correct false. Plug this in here. Get nice and pretty. Come on, thank you. And so we'll just go ahead and break this loop because we don't need to check anymore if something in the code is incorrect. But if it is correct, I'm back. I thought I smelled something burning, so I had to go check the house. All right, so if it is correct, then we want to do something like open a door or something like that. So let's go ahead and get a branch here. Slap in our is correct. Go in there, thank you. If it is correct, then we want to open the door. If it's not, then we want to go ahead and grab these puzzle pieces again. Do another for each loop. This time we don't need a break, so we'll just do for each loop. And then we want to get all of these guys and say get color index. So each time, not get, sorry, set color index. So for each one of these, we want to set it back to 0. And then we can actually go ahead and say update color. And update it all back to being the first color, which is in this case white. All right. And now that actually should be perfectly good for failing, but let's go ahead and try and make a success thing. So we need to make a door. Actor. Let's just call it BP door. We're gonna open this up and go really fast on this. So we're just gonna grab a cube and I'm going to set this cube to be like 0.25 on the X and maybe 2 on the Z and 2.5 on the Y. Okay, and then let me put this in the world really fast. Door. Raise it up. Yeah. Okay, there's the door. And then I'm going to duplicate this really fast. And this is going to be called open position. And I'm going to scroll down here, set its collision preset to no collision, and look for hidden in game and set that to true. So all this is going to be is where is this door going to end up at? So in this case, it's going to go to the, actually we want it to go to the left, so opposite because I'm looking at this from the back, I guess. There we go. Anyways, so that there's that. So now we want to have this open up whenever it's being used. So we can come over here to our class settings, also implement a use interface. Open that up. And we want to say if this actor here is the checker, and if it is the checker, then we can go ahead and open the door. So we actually use a gate here. Say open, Whenever this gate is open, then we can get a v interp2 constant. We can get the cube's world location, cube being the door itself. Get world location, there it is. And then we can get the open position, copy paste this world location, plug it in here. So for our current, that'll be the cube's world location, and for the target is the open position. The delta time, we can actually get that really easily from just doing an event tick. Go. And we can plug that event tick into the enter, and then the delta seconds into the delta time. I want to bring this forward a little bit so it's a little bit cleaner. There we go. And the interp speed, let's do like 60. All right, and now we can hit that cube and say set world location. Plug this in. Again, the return value there, and whenever this gets called, it will open that door. Okay. And then back in our checker, we can say, actually, we probably need to do this as a do once. But if it's correct, we'll do this next part just once. And that will be to get our door actor. So we need to make a new variable called door to open. And we can actually just make this of type actor. We don't have to reference a door per se. So just make sure it's instance editable. And then we can get this. We can right click and convert to validated get to make sure it does exist. And then I don't think we have to make sure that the interface exists, but let's do it anyways. So we can just do does interface and or does implement interface, and then we can say use interface. If it does, then we can do our use message. There we go. And in this case, the actor being passed through actually matters, because we want to make sure that it is the actor that is using it. That's why we have that cast there. So we will come back here and say, get a reference to ourself in this case being the checker. That should be good to go. Probably a little bit more logic than what we actually needed because of the get and stuff, but it's just nice to make sure that, you know, things are implemented the way they're supposed to be implemented. All right. So now I should be able to click on our checker here. And since we already set up our colors and we set up our code, we can now just click the side dropper and say this is the door or the other actor that we want to open or whatever, whenever we want to use it, whenever we win. So this is 312. So we can easily type in that code. See, we have 312. We can kind of do it based off of okay. 1, 2, 3. Okay. 1, 1, 2. And is the code wrong? Well, if the code is wrong, it should be saying something about it. So let's go ahead and do a print string on both of these. This is how you can do something pretty easily. You could say like should use. All right, let's actually check the door really quick. Loop checker, but yeah, that should be fine. Should use. This one could be should fail. And we can even do like you can do strings for all of these things. So this could be like actor or door does not exist. Maybe door does not exist. Copy paste. So this is a nice way to really find out what's going on with your code really fast. Okay, and this one is does not implement use interface. Then we can actually go into our door here and say paste this in and say cast failed. So if any one of these get triggered, then we should know what's going on, right? Run over here, and what was it? 1, 2, 3, 1, 1, 2. E on it, and it says should use. So it is getting to the use point right here, right? So at that point, we want to go and check the actor that we're supposed to be opening, make sure that this is correctly clicked on. There we go. We get into here and we need to make sure that it is actually opening. We didn't see a cast failed, so we should be seeing this. So if we print a string, this will actually print probably multiple times. We'll just throw a hello there just for the heck of it. It'll probably just start spamming hello. Should fail, should fail, should fail. Oh, because I'm dumb and I didn't do the puzzle. Let's go 1, 2, 3, 1. Wait, whoops, screw that up. Wait, okay. 1, 2, 3, 1, 1, 2. All right, then we hit E. So it should be opening. So then that means our issue is somewhere else. So our V interp to constant in the world location of the cube, in the open position. Our open position is separate from our main position. Let's make sure that's the same in the world. Yeah, you can see it there through the wall. Okay. Open position. V interp to constant. Delta time. Interp speed is 60. We are moving the cube. Curious. Open position, not that. Okay. I am very confused. It's got to be something really, really small and dumb because it's got to be something here. We are moving the cube, getting the cube's roll position. We are getting the delta time from the tick. Open is happening. Cast is not failing, obviously. Let me put this under the screen. That should be working. Okay, 1, 2, 3, 1, 1, 2. And then we're gonna press E. I'm actually watching this on the other screen right now. You can see it is getting here. It's getting all the way to print, all that good stuff. But for some reason, it's not interpolating. Eight. 975. Are those numbers the same? 1758.529358. 1758.529358. Yep. 975.475. 975.475. Okay, so these numbers are exactly the same. So basically these two vectors are the same. Why are these two vectors the same? They shouldn't be. Yep, because they're not connected to each other. Wait a second. Wait a second. I have two different doors here. That's why. I put down two doors for some reason. So now when we have this, we need to come back in here and make sure that it is set to the correct door. Okay, that was weird. 2, 3, 2. There we go. So it wasn't the code at all, it was just I put down too many doors for whatever reason. Now we can go through and we can delete all of our print strings really fast. And there we go. Sorry about that, that took a little bit longer for a really dumb reason. But at least you can see kind of how I figured out what was going on. But yeah, so we can set this, let's set this to like the wrong color. You notice it switched back, so we can just set all the green really fast, and we know that's wrong. E switches back. But if we set it to the correct color code, which is 3, 1, 2, hit E, the door slides open. So there you go. That is how to make a quick and easy 30-minute long light puzzle. I hope you guys enjoyed it. If you guys have any more ideas or suggestions for puzzles, please leave them in the comments below. If you liked the video, please leave a thumbs up. If you didn't, leave a thumbs down. Either way, it kind of helps the video, so thank you. And then I'll see you guys next time.